The broadcast is now starting. All attendees are in listen-only mode.
Hello and good afternoon, everyone. My name is Anna Zylik. I am with ICF, and we are the vendor working on behalf of the sponsors of Energize Connecticut to bring these passive house and all-electric homes trainings to all of you. So thanks for joining us today. We will be recording this training and we will make this available afterwards. These trainings are at no cost thanks to the sponsors of Energize Connecticut and are part of a partnership with Connecticut Passive House. A quick reminder that as part of this training and workforce development initiative, we are offering a 75% cost reimbursement for individuals pursuing either FIAS or fee professional accreditation. So this includes the cost of the trainings and the exam. And once you become certified, we'll work with you to process the 75% cost reimbursement. So if you have any questions, please don't hesitate to contact us. With that, I will pass it over to Nate, who also is with ICF, to talk about the Passive House and All-Electric Homes building incentives.
Thanks, Anna. Hello, everyone. We're excited to have you here for today's webinar. In addition to the no-cost educational training series and the professional accreditation reimbursement, the sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to go all electric with their residential buildings or pursue passive house certification in multifamily projects with 5 or more units. All right, next slide. There we go. Okay.
Sorry about that.
The passive house design for Energize Connecticut is shown here on the slide, and incentives include pre-construction for feasibility and energy modeling, and post-construction incentives for passive house certificate for full passive house certification. All right, and the all-electric incentives for both single-family and multifamily buildings offer 2 levels of eligibility with specific design and performance requirements associated for each. And has incentive amounts ranging from $1,500 per unit for multifamily up to $10,000 for single-family homes. Our goal is for everyone involved in residential construction in the state of Connecticut to be aware of these incentives. So for anyone interested in learning more, please visit our website or contact us directly on the address on this slide. As for questions during today's meeting, please feel free to use the chat function throughout, and I will relay them to Scott, and we'll answer these questions at the end of the meeting. And with that, I will turn it over to today's speaker, Scott Johnston.
Thank you, Nate. Appreciate it. Also with me today is Paige Malloy too. And before we get started on today's presentation, I just thought we'd introduce ourselves. So Paige, if you could introduce yourself to the folks out there today, that'd be great.
So I'm Paige Malloy. I'm the Territory Sales Manager for Timber HP that covers New York, Connecticut, and Rhode Island. I joined in April, but I have a background in insulation as well as different WRB systems. So very excited to be here and working with someone like Scott Johnston.
Thanks, Paige. And a couple slides from now, I'll have Paige's email along with mine as well too, so that you can get in touch with us. So my name is Scott Johnston. I'm the Business Development Manager for Timber HP, basically covering all of the Northeast at the present time. My background has been with Anderson Windows and Doors for commercially, residentially, all throughout the Northeast. And I also had most recently been working with Huber Engineered Woods on the commercial side. So my built environment is quite solid, especially with fenestration and insulation. Have experience with that with the R sheathing that Huber Engineered Wood has. So great opportunity to jump over here with Timber HP. I live in Maine, so the story here is just fantastic. Today we're doing an AIA presentation, but I encourage any of you that are on this call to reach out to Paige or myself. We certainly can come into your office, do this same presentation that we'll show you here in a few minutes, or we can also do a product knowledge workshop too. The website, timberhp.com, is always a great place to go to get current information as well too. So let me just give a high overview for who we are. For those of you that are new to us, perhaps some have been following our story, and many people might know us as GoLab, but our new go-to-market name will be Timber HP. And really what we're looking at is three pieces of the business, if you will. We first and foremost look at the product in and of itself, because we're looking to use our products as a drop-in replacement in wood frame construction as an alternative to what's out there today. So obviously high performance means that we're going to provide you with the R value that's necessary for code, a durable material for the installers to work with, and beyond just simply R value, of course, we're going to also be able to provide some sound enhancements as well for acoustics. The other piece of our business, we talk about Timber HP for high performance. We also talk about Healthy Planet, with the exception of cellulose, which also is recycled material from newsprint. We're really proud in the fact that we're actually able to use recycled material from producers in the main wood industry that are making dimensional lumber, interior trim, etc. And we're able to take their waste stream and incorporate it into our product. So it's really great. It's a renewable product. It's abundant. It helps mitigate cost. That allows us to come in and be cost competitive. Whereas up until this point in time, any wood fiber insulation has been imported from Europe, which is very expensive. And then lastly, of course, we look at Healthy People. And here we see a great family having some fun in their home, but we're also thinking about the workforce too that installs insulation. So we're really bringing something new to the industry to make the product go in easier to handle. It's not scratchy, itchy, scratchy. When you're cutting it, it's just wood fiber. There's no other particulates. So it's a pretty unique product that we're bringing here to the United States. And we'll be producing this, and we actually just started producing our timber fill. That's being produced up in Madison, Maine. So we're really excited about that. But really, in essence, like I said, it's a drop-in replacement. We're going to have what we call timber bat for your cavities. We're going to have timber fill for blown in for the attic and for dens. And then we'll have timber board for continuous insulation to the exterior. And, we look at this, and many people are looking at insulation for many different reasons. One of the things that we're excited about is we are able to look at this product as a decarbonized, in this case, carbon storing, if you will, story that we think is pretty impactful and powerful. High performance, what's interesting here, we're talking about flow-through assemblies. We're really trying to help mitigate any moisture that gets trapped in that wall cavity, and we'll talk more about that during the presentation. The material in and of itself can be recycled. We're using non-toxic materials to help produce this material, but by and large, 90 to 95% of this material is wood fiber, and that's it. And certainly we do treat the interior, the bat, and the fill to address Class A and Class B flame shred, and we'll talk a little bit more about that. My last slide before we get into the presentation, this always comes up, especially for those of you that have been patiently waiting and following the story for many years now. Paige and I are really excited to the fact that we are producing timber fill. In fact, for the presentation, I brought proof of life. So this just came out and was produced yesterday up at the factory. So the production lines, the first production line is up and running, and we're a couple of weeks away from having our final certification to allow this to be ready to go in terms of specification. Then the timber bat, we're going to be working on that this summer, and we expect to have that ready for commercialization probably October, November timeframe. That equipment is in place. It's just a question of bringing that equipment in and getting it operational. And then the continuous insulation, which we call timber board, that'll be ready for late December, but probably most likely early January. All of the specifications for these products are out on our website as well as ARCAT. So if you're looking at projects, we are good to go in terms of helping you with specifications. All of the pricing is also available, and we have distribution, and we're slowly bringing on our dealer base. So I'm going to put my name up here. As you can see, my contact information and Paige's contact information is there as well. So if you have a project and you want some budget information, give us a call. We'll learn more about your project, the timing of your project. If there's a contractor involved, we'll get them involved, and we'll actually do some budget pricing for you to see where we come in. but we do want to make ourselves readily available. But with that, I'm going to take a little pause and we'll shift over to actually doing the presentation. Nate, do you have any chats that have come up before I get started, or are we good to go?
I am not seeing anything yet, so I think we're good to go.
Right. It looks like Paige's computer's down, but that's okay. So thank you everybody for joining us, and I've purposely left this slide up. If this is a presentation that once we've gone through it, that you think is useful, not just for yourself today, and you'd like us to come into your firm, we certainly can arrange to do an in-office presentation. We're more than happy to do that, and we can also bring in samples so you can actually take a look at this material firsthand and get a chance to see it and touch it as well. So solving performance demand using wood fiber, and the reason we say that is the fact that now more than ever, of course, insulation is being used in our buildings, both commercially and residentially, because codes have changed. We're not just looking at putting insulation inboard to the buildings now. Of course, continuous insulation is a pretty mainstay item now. And so for that fact, now more than ever, if you're the one that's making a decision in terms of what is going to be used in that building, a lot more thoughts going into what is that material am I using, not just from a performance standpoint, but also embodied carbon, recyclability at end of life of the building, etc. So that's really the point of the title for this presentation. We're going to capture all the information in terms of attendees. It's going to be critical to make sure that you provide your name and AIA number so that we can submit that for you. Do you guys want to go over that process before we get into the presentation?
Yeah, I can mention it really quickly. I will be sending out a couple of surveys. One survey will be requesting feedback on today's presentation, and the second survey will be specifically to collect people's AIA information. So be on the lookout for those two surveys.
Awesome. Thanks so much. I appreciate it. Now my slide is not advancing. It worked fine up until just that moment. Did something happen there, Anna, when you clicked over? There we go. Got it.
Good.
A little bit of a delay on that. So this is what we'll be covering off on today. Really, part one's very quick. We'll spend a good portion of our time today talking about wood fiber. What is it? We'll have a brief overview with regard to code compliance. And then certainly, depending on how our time is, we'll talk about embodied carbon too. Here's just an interesting placeholder here for the first section of our presentation today. This is a building up in Mount Desert Island, Bar Harbor, Maine. And this is wood frame construction. It's a commercial building, about 30,000 square feet. And you can see the zip system there, that's sienna red. So this is a traditional wood frame building. And here what they've used for continuous insulation is Gutex. It's a wood fiber continuous insulation that was shipped in from Europe. But what's happening now, as you all know, and you're in Connecticut, so it's not as stringent per se as Burlington, Vermont, or Maine, or New Hampshire, and or Mass for that matter. But continuous insulation now is becoming a mainstay, driven by codes to help with thermal bridging, obviously. And if you look at this slide, 2003, you really didn't see anything related to continuous insulation showing up at all whatsoever. And 2018, which seems like an eternity to me, it's pre-COVID, but you saw back in 2018 getting closer and closer to almost half of the insulation that we're using in our buildings, particularly up here in the Northeast, are going to have continuous insulation. And more of that will be used, and in many codes, obviously, we're going to be going to thicker dimensioning on that as well. Obviously, that's for thermal bridging. We're looking at a wood frame building, and by and large, this presentation today is really talking about wood framed construction. And in these applications, we have a house here that we're showing you with the infrared, but that could be a multifamily project as well. 20 to 25% of that wall are 2-bys, and that's a beautiful thermal bridge. And so obviously with code and many early adopters many years ago, they were looking to put exterior insulation to try to minimize that thermal transmission, if you will. Back in the day, 2x4 was the mainstay of construction. There was nothing problematic about that structurally. We did grow that to 2x6 to get a deeper cavity to put more bats in the wall, but that did not negate that thermal highway with the 2x. So today, what you see here flanked on the left and the right, we see foam being used, we see mineral wools being used, we see an R sheathing with a polyiso being used. So there's a lot of different options out there today for you to look at to try to address those concerns. The bulk of the United States today is really still continuing to use foam plastics and fiberglass as the mainstay. So about 90% of that market in the US for wood frame construction is made up of fiberglass and foam boards. Certainly mineral wool has over the last 10 years really picked up. A lot of folks are very interested in that material. And here in the Northeast, I think you've seen it quite a bit, probably not only for type 3, type 5 per se, but certainly you see that used quite a bit in type 1 and type 2 where non-combustibility is critical. So that's really the bulk of what we're seeing in the United States today. What's also interesting is the history of insulation in the United States. And insulation as just a mainstay product available locally really never occurred until the 30s, and that was fiberglass. And still to this day, as you saw in the previous slide, fiberglass is a pretty dominant material. It does a good job in terms of the thermal performance. It's easy to cube out a truck and get a lot of that material in and out of the manufacturing facilities, out into the market. It's fairly easy to install, and the price is very, very low, if you will. Here, that product has gone through a lot of different variations, but nonetheless, still it does get to be a bit of a challenge when you're looking at floor door tests, air barriers, and such, because you do worry about the installation quality, because that craft paper can hide a little bit of that installation sin where you might get some wind washing. But nonetheless, fiberglass is still a very viable product that's out there today. Foam and plastics post World War II, of course, biggest producer of oil back at that time. So oil-derived foams, if you will, started to come and become mainstay, more so commercially at the time. Although over the last 10 years, as you know, we've started to see more and more of these exterior continuous insulations being applied to residential and multifamily as well. Mineral wool too. I mean, I guess if you can take cullet, recycled glass, if you will, and make insulation out of it, because really with insulation, we're just trying to get that air space to help with the R value. So why not make it out of rocks as well? So back in the 50s, mineral wool was created, and some of the benefits of the mineral wool is its durability. As I mentioned a minute ago, certainly great for fire resistant and actually non-combustibility. So that's why it's able to be used in type 1 and type 2. But it also can be put under slab and up against foundation, so that it has some great properties there with regards to not decaying with water and such. Of course, obviously it has its challenges as well. It's a mined material for one, also needs to be heated up to some extreme temperatures. So there's a lot of energy that's used to produce the material. And then in the 50s, it's pretty interesting, long before recycled materials and embodied carbon and sustainability was even a thought back then, if you will. Very early on, somebody had the great idea to take newsprint and recycle it and blow it into the attic space, which was great. And that worked out very well in the 50s, 60s, 70s, 80s, 90s, and the early aughts, because there was a ton of newsprint around. But as of late, of course, digital media is really what's being used today. So for those of you that are not aware of it, and if you have been using cellulose for many, many years, it's a great product. But they're really having a hard time finding what we call the raw material, which is referred to as feedstock. So that's been a big challenge for them, but a very interesting product. And of course, that's evolved not only into blowing it into the attic space, but obviously over the years, dens packing is something that's used quite often here, particularly in the Northeast. And then of course, cotton is just one example. example, you could put hemp there. You could certainly put wood fiber as it was being imported from Europe. A lot of other different materials have been looked at as insulators, if you will. The bottom line with insulation production, though, is it has to be able to be a material that's viable, that's plentiful, and that's durable and provides, you know, code compliance, if you will. If it's not, first off, if it's not, you can't sell it if it's not code compliant. But if that feedstock starts to wane, then it becomes hard to get, and the prices go up, and then oftentimes you'll see something, you know, no longer be in vogue, if you will. So that's really kind of a snapshot into what's happening in the United States. And this next phase here of the presentation really speaks to wood fiber. And I'm sure there's a number of you on this call that have used wood fiber from Europe that you've specified into your projects, or if you're a subcontractor or a CM, perhaps maybe you've managed projects where wood fiber has been incorporated into your projects. And that's been, up until this point in time, been imported. And that kind of throws back to that cotton insulation category. You know, importing it from Europe really thins that market in terms of where it fits because of the cost. So now being able to produce this material here in the United States, where there's an abundant forestry industry, plenty of raw material, finally now we can look at this as a category that is affordable, not just for that large square foot home where people have the means to do it, but also to be able to actually look at this now as a viable product to even get into affordable housing, so that we can look at this as something that would be a mainstay and commercialized, ready to go. We showed this slide a little bit earlier, but again, here we can finally look at a material that is coming from upstream producers, where we can take the residuals and we can take that wood fiber that really is either going to be burned in a biomass plant, it's either going to be used for newsprint. Unfortunately, as I said earlier, newsprint is kind of going away, so a lot of the forestry folks have lost that market. So today, if it's not going for newsprint or paper, if you will, it's being burned off in biomass, or it might be used in some things such as bedding and things of that nature for pets and horses and the like. But now what's interesting it is now being made domestically in the United States. Now we can capture that wood fiber, put it into a finished good that's viable here, in this case as an insulation material, both for sound and for thermal, and we can sequester that material into the product. The high performance nature is really kind of interesting, because for many of you on the call, you know, when you're looking at that assembly, that exterior envelope, if you will, you're going to either have vapor open perhaps with a mineral wool per se, or you're going to be using a non-permeable exterior insulation, which means you're forcing, and code's helping you with that, prescriptively helping you understand how to get that moisture that is in the wall to dry out to the interior. So you're kind of losing both abilities to dry out interior and exterior. Here, this product allows us to actually dry both to the interior and the exterior. We'll show you some slides on that as well. The material can be recycled. So we do talk about circular economy now when we talk about wood fiber. And then, of course, you know, we need to be mindful of what the materials are. 90 to 95% of it is wood, but there are some additives to help us with fire, bugs, and water, as well as, for example, the bat, the density of that bat. We have to put some materials in there as well, which we'll talk about. Really interesting. We're all skeptics here in the Northeast. You go first type of mentality before I go ahead and stick my neck out and try a new product or specify a new product in this case. But what's really fascinating about this category is it's actually been in play over in Europe for about 20 to 25 years. These brands that you actually see here are mainstay. So if you were building a home over in Europe, which is only about 30% wood frame construction, here in the United States, we're actually 70%. So there's a tremendous amount of running room here in the United States. You would see these types of brands just readily all throughout the market. Styco, the upper left quadrant there, you can see that brand name. A little company called Kingspan just bought 50% ownership of that company. So, you know, that's a very large insulation company in the top 2 of the United States. So they see obviously that wood fiber is a very important market that's only going to get bigger. And we did test this out last week. I'm going to play a little bit of a video that we've kind of snipped away some different installation vignettes from these various manufacturers over in Europe. So for those of you that are brand new to wood fiber, it's going to give you a little bit of an indication of how it's installed, how it cuts. And if the music doesn't play, that's fine. It's purely background in music, if you will. But take a look at the structure, the installation, the first little vignette after the slide that shows. It's always nice to have a promotional video when you have the Alps behind you. It's pretty cool. So, normally when I'm in a smaller group setting, I'd ask, what you saw in the video that was unique and different. But we can't do it in a group of this size. But a lot of what it was that you didn't see anybody suited up in protective gear. You didn't see gloves per se. You did see a couple of masks dangling from the installer's neck. Ideally, that paper mask, if you're cutting a lot of that, because it is sawdust and you still don't want to inhale sawdust. But other than that, from a protective equipment aspect, that's really all that's necessary. There were some different cutting tools that you might have seen in there. One person in the group thought, why is there a chainsaw inside to cut the bat insulation? And I helped them understand that was just simply a battery cutting tool to help easily cut that material. But really, all of those materials are pretty interesting in the sense that anybody that's doing cellulose material today, they can use the same equipment and blow that into their attic and or dens packing. So it's pretty interesting in that regard. And then in terms of cutting, if it's the board, you're cutting that on a table saw, or a skill saw can simply cut that. And then for the bats, there's different simple, in essence, bread knives, if you will, to make it easy to cut, but a very, very intuitive material to work with. So not really any education that's necessary to spend too much time other than about all of 5 minutes. But really, the great part of this insulation story is the raw material. And that raw material is coming from trees. And obviously in the United States, we're cutting trees for the built environment, for whether that's sheathing, or in this case, you can see dimensionally some dimensional lumber, interior trim, etc. There's a lot of producers out there that produce a lot of material, and they have residual fall down material. And as you can see in that second photo in from the left to right, you see waste chips. And that's really what's recovered from the production that's either burned off, as I mentioned, in that biomass, or could be used and sold for bedding and things of that nature for animals, or sold to paper companies. And as I said earlier, that's getting less and less because there's less and less producers in the US, or it could be sold to a company that's making wood fiber. That's one element of it. What's really interesting here is that in Maine, yes, that's what we're using to produce, because there's just such a plentiful supply from these producers of those chips. But we could go out to other parts of the United States and put a facility right next to another big entity, a Boise, a Weyerhaeuser, Roseburg, you name it, and pull off some of their waste stream materials such as tree toppings, branches, and the like, and still take that product that would either decay in the woods. We can take that, provide them with a cost, if you will, and they like that certainly, particularly with the publicly traded companies. But we can take their waste stream and create the wood fiber material. So the bark is used. That's going to go to bark mulch and things of that nature. But we're able to take that waste chip, if you will. We finally grind that material. We're literally shredding that material. There's 46-inch plates that peel apart, grind that material so that we can really get that wood fiber exposed. And then you see that little eyedropper, if you will. What happens is we're steaming, grinding, and then depending on the product that we're making, we're going to put in some additives to help us with regards to, in the bat's case, to give us the profile, the density that we want. And in the fill, we're introducing a liquid borate, and we'll get into that in more detail. And then for the board, we're using some different materials there. We're using an MDI resin, very similar to the OSB manufacturers, and we're also using paraffin. But again, 90 to 95% of that insulation is actually wood. And that's fantastic because there's so much of it here in the United States, and that really does help keep the cost down. The main markets lost 4 million tons of that low-grade wood. They lost the ability to sell that to the paper mills. So if you're a forester, some of your profitability at the end of the year, depending on how the markets are rolling, that additional ability to sell to the paper mills was vital to their business, and they've lost that, unfortunately. So we're able to reclaim that. In fact, the mill that we're using up in Maine is a old paper mill that was defunct in 2016. And what's really cool is we're able to reconstitute that relationship with those producers and pull back in that raw material and put it back into a viable finished product. This is a real exciting point. It's fantastic. I live in Maine. I love the story. It's in my backyard. It's so vital to me here and where I live. But what's really great and compelling is that this is a U.S. story. So you can look at this map of the United States and start to look at timberland, and you can start to extrapolate out of that this Madison story that we have can also be duplicated where you see other forestry industries in the U.S. and where you have other producers today producing products where these mills could go in and capitalize on that feedstock, if you will, those raw materials at a very low cost, doing good things for the forestry, obviously, getting that material out of the woods, but then also being able to make this wood fiber insulation, not just in Madison, Maine, but other parts of the United States. Cost is critical. We talk about sustainability as it relates to the environment, but as a business model, you have to have financial stability. And so the only way for the Performa to be able to invest to put the mill in Madison was such that this could not be a boutique product coming into the United States. It already was. Shipping it from Europe meant that there was a tremendous inherent cost with it. So when you start to look at it domestically for all the reasons I just stated, now you're able to really pull that cost down. So when you look at cellulose, for example, their costs are going up. It's harder and harder to find that raw material. Here with the wood fiber, plentiful, very easy to be able to come in, produce that, and provide parity in pricing. And we're just going to market now. We believe we'll be at parity, but we actually might be a bit of a cost saving, depending on the narrative of where the cellulose producers are going. When you look at the continuous insulation board, the exterior insulation, for example, foam boards, they might have a higher R value. So for example, you might be looking at an 1.5 inch board with foam to hit a particular R value. With the timber board, you might need to bump to a 2 inch to get that R value. But the really cool thing here is that the totality of that cost per square foot is still at parity with foam. So that's a great discussion when you're talking to an owner, be it a commercial or institutional individual that you'll be working with, or if it's a homeowner. You don't have to have that pricing discussion to say, hey, I'd like to use this product, but it costs more. That won't be the case here. And if you've been using mineral wool, you'll find here, particularly in the East, and you're in Connecticut, so you're right within that sweet spot for distribution, you'll find that that is going to be a bit of a cost savings to move from mineral wool to a wood fiber. Of course, specifically in that type 3, type 4, type 5 category, because the wood fiber is not to be used in the type 1 or type 2. I will say, though, that with the bat, and you saw on some of the earlier slides, fiberglass is still a pretty mainstay product out there. They can cube out a 53-foot truck and get a lot of that material in there. So the fiberglass is still going to be quite a bit less. But if that's not what you're using today, and I would argue most people on the phone probably use that very rarely, but if mineral wool is something that you've been using for bat, you'll find that, again, based on the fact that you're in the Connecticut area, not too far from the plant in and of itself, and will have very robust distribution, you'll find that we'll be coming in less than the mineral wool product. So drop-in replacement. Anything that's above that foundation, that's wood frame construction, and whether that's the cellulose or the mineral wool or the foam boards that you're using, you can very easily detail and specify any of these 3 products that we've been discussing here this afternoon. So whether it's foam that you've been using or mineral wool, cellulose, fiberglass, etc., wood fiber certainly does have a place in that structure as long as it's above the foundation. Now you can use it in basements and conditioned space, but we want to make sure that it's very, very similar to that building enclosure, wood frame construction, wherever you're doing that level of design. The wood fiber is a great replacement. And here's a couple just images. Obviously, code compliant is critical here, and all of that information will be available. This is thermal as well as acoustics, single family, multifamily, and that would be, when I say multifamily, I'm speaking, obviously the first thing that comes up is the NFP 285. So I'm talking about 4 stories or less. There's a good fit for us there. As you can see there, and then mass timber, and then certainly factory built solutions. There's a lot of interest with regards to system built, and those that have been importing from Europe, Passive House Net Zero folks, I think you'll find that this is going to help on that line item, and you can maybe find a cost savings here now from what you've been importing. But Simple Dens up there in the top left, on the right is a main home that's getting a deep retro, where they're actually putting outbound continuous insulation, new windows. That lower left, that's that College of Atlantic job where they're using continuous insulation, and then you can see an example of a system-built project below on the right. So very simple discussion here with regards to product. There's 3 products that we'll talk about. The first is what we call loose fill here in this presentation. This would be your alternative to cellulose for the blown in for the attic and or for the dens. It's exactly the same installation, same equipment that's going to be used. And what's exciting there is that this is not just for new construction. If you look around New England, there's a lot of incentives out there. Obviously, we're on a call today supported by some incentives out there for weatherization programs. So we're really excited to partner with folks that are trying to find alternatives to what they're using today to consider wood fiber for those weatherization programs. Question comes up, what material, what is the wood that you're using? And for all 3 of these products, we're using softwoods. And so that's really primarily in Maine. There's a tremendous amount of harvested, softwoods that are being used for that dimensional lumber and that interior millwork package, if you will. So we're using softwoods. And 95% of this product is wood, then 5% by weight would be boric acid. That boric acid is liquid. A lot of the cellulose folks are using powder. We like the liquid because it's going to be infused into the fiber, and that's really taking care of our concern about fire, so we are code compliant in addressing that. And then it's also going to help us with regards to mold mitigation. So if you had a failure in the wall cavity or up in the attic where an area got wet, as long as you catch it early enough and you can remediate where the breach was, this material will dry out, and you're not going to get that pungent odor that you might get with an ammonia. The material will dry out, and that borate helps to mitigate any mold concerns that you'd have. The material can take 15% by weight and still provide that R value as well. And then the other piece here is that the insects do not like to ingest it. So there's no concerns there about the material being eaten, if you will, by insects. We're looking at a 3.7, 3.8 per inch is what we're looking at, which is very comparable, right on the money, if you will, with regards to the cellulose manufacturers. So really quite simple, and that gets us an ASTM E84 flame spread A. And we'll show you, once we're done with the bat slide here in a couple of slides, we'll show what borate does. But if you've been blowing cellulose and you're familiar with that, they call it the penny test. And so the first thing anybody that's been using cellulose does when we visit and they're learning about this product is they grab a clump of our material, put a penny in it in the center, and take a blowtorch. And what they want to find is that they can liquefy that penny. Yes, you'll find that the fiber will burn in and around that area, but once that melts and the blowtorch is turned off, the combustion ends. There's no char. There's no continued combustion. It does not support combustion, and that's what gets us with the code compliant. It really helps us address that quite easily. Bats, here again, both with the fill and the bats, not only thermal, but we can also address the sound aspects of it as well too. So demising walls, both of these are really great applications to be considered for single family and multifamily and other commercial applications. Same softwoods. So all of our raw material coming in can make fill, can make bat, and also the continuous insulation. What we're putting here in to this product is we still use the borate, but then we're also using a PMI, which is really a polyester material that gives us the density that you see and the pliability that you see. And so here we're at about 90% to 92% wood, and then the two non-toxic additives would be the PMI and the borate. Basically like and I don't, Hampton Inn, I guess I stay at a lot of Hilton, so I use them. If you go down for breakfast, they have that big toaster oven. And so in essence, what you do and what you see in the manufacturing aspect of this particular product is the wood fibers coming down in, and you're slowly then adding these additives in that are cooking into the material so that it permeates all the way through to be able to give us that fluffiness that you're seeing in the upper right image. And that really helps us get to that R4 per inch. Nothing new here in terms of your dimensions. We want to keep it simple for specification and also for ordering it at the lumber yards. 16 and 24 inch on center. You have your 3 inch, your 3.5, 5.5, 6 inch, 7.25 to address your steel and your wood studs. So really great product here again, ASTM E84 Flame Spread A. This is a pressure fitted product that you can see right there. There's no need for any craft paper. This is a very vapor open material, so we're not worried about that. Very dense material, which helps us on the thermal as well as the sound. And you're literally, if the framing's done on the money, you're literally just pushing that into the cavity. If it's remodeling and you need to cut it, it's just simply being cut with some cutting tools and very easy to install. Here's the borate. There's no sound on this, but really taking a blowtorch to it. If there was no borate, that cube of wood fiber would have just torched. It would have just gone right up. The borate slows down combustion, and obviously codes dictating that to us because we want the occupants out of that house. And once you take that flame away, extinguish that, you'll see that the borate will then snuff out that material. In essence, chars. And then also it's not dumping in a lot of the plastic, nasty chemicals that you'd find with other building materials. It's really wood, and the firefighters are quite used to that. We've actually had a lot of support from that industry. So when they're fighting fires, they know what it is that they're going to fight with regards to these types of products. It's something that's very familiar. The continuous insulation board is a bit different. We're going outbound now to the structure. So what we're doing here is we're going to start to use an MDI resin, and that's more in line with an OSB board. And I have a little sample of it right here, and also a larger one here. It's hard to visualize it here, but the PSI on this is quite a bit more robust than a mineral wool. It's hard for me to compress that. And so what's really important is the durability of it on the job site. But when they're putting up the rain screen, mechanically putting that 1x strapping, if you will, what's great is with the wood fiber, it's really helping you get a consistency from one application to the next to reduce that telegraphing concern if the installer of that mineral wool is not being mindful of the depth. So it's quite a nice product to work with out there in the field. And you can see upper right, he's cutting that just simply with a skill saw. So here we're going to be able to produce anywhere from a 1 inch all the way up to a 9.25. You'll see very standard sizes that will be offered straight away in dimensions, and then a 4x8 panel, all really to provide you with just some simple math. So as you look at your climate zone, you're going to be very, you'll find it very easy to be able to pick your continuous insulation in concert with your bat in the wall to be able to do the math to be able to get to the compliance that you need. Here, we're not using borate. So right now, we very easily fit in a type 5, it's combustible, and we're working and doing some fire testing assemblies, if you will, to get into that multifamily. And it depends on whether it needs to be 1 hour, 2 hour, depending upon the location of that building. We're doing a lot of modeling to try to get in there. We know that we'll be able to get into the more rural multifamilies, but as we get into the more metro, a little bit more challenging. But we do believe that we might be able to put some borate into this product, because right now this is an ASTM E84 Flame Spread B, but still fantastic out of the gates. Here we put a blowtorch to it, and really what you get is charring because of the density of it. But still, right now we have a tremendous interest with multifamilies, retrofits as well, and even actually some distribution facilities. We're also working with somebody to get to, and I know, don't laugh, I'm glad you're all muted, a net zero airplane hangar to help offset that carbon for the fuel being used. There's a lot of unique projects that are being looked at here with the continuous insulation panel, with that ASTM E84 as it stands today. On the right, you're just going to see the action of the paraffin wax that's used. And I've got to tell you that all these materials are integrated through and through. So if you were to chunk out a piece of that material, you're still going to have the paraffin and the MDI material through that material. The other cool thing about it is if you look at those non-OSHA approved stairs, those were in play for 6 months. Matt O'Malia designed and managed this project. And those stairs, those temporary stairs were used for 6 months where that material was drying, getting wet, people going in and out and sitting right there on some sand, as you can see. So very rugged, durable material. So I want to be mindful of the time. I think we have till 1:30, but I want to try to tie this and shorten it up so we can have some questions at the end. But here is what I said earlier in the previous conversation, at the beginning of this category here, was the fact that we can have flow through assemblies. That white centerpiece is your OSB or your plywood, and you can see the black. That dotted line, you're gonna pick what you're gonna use for bulk water management and air. But really, in theory, if you're using these wood fiber products, you have the exterior continuous insulation board, and then you have the bat. And if you had some type of bulk water problem or high humidity issue, physics is going to take over. Your board, the panel, if you will, depending on what it is, that range is anywhere from 2.5, 3, upwards of 6, depending on what they're using for their MDI resin or if it's plywood, but it's not 0. So if you do have a condition, you'll see that physics will do its thing. We had 3 weeks of rain. I'm sure you did as well not too long ago. So if you did have a really big issue where there was a lot of moisture in that wall cavity and the sun hit that exterior wall, it would be able to draw that material out through that OSB, and then it would hit that very vapor open of about 40 to 70 perms on that exterior board and pull that water out. But it's like Gore-Tex too, so that to the exterior, if you don't have your cladding on yet, you can pummel that with water, and that water would bead off because of that paraffin that's being utilized on it. Exposure rating there before the cladding's on is 6 months. on the wall, and then 3 months up on a roof decking. And the material in that situation literally could take upwards of 15% in moisture and still be able to perform at its rated R value. So pretty interesting, kind of throwback to the felt paper back in the day. You know, here we're able to maybe perhaps allow you to start to look at that exterior wall condition and think it through a little bit differently than you had been with the insulation and codes that are now in front of you today. So low thermal conductivity, high heat capacity. So this is pretty cool. So now we're talking summertime. Let's talk about either an exterior wall or let's talk about the roof, if you will. It has the ability to really truly deflect that heat gain as well. So we want to always remind everybody it's not just solely about the cold months and trying to keep our homes warm or our buildings warm. We also have to think about cooling costs. And this is just a little bit of a vignette that we've done. We tested it also at the University of Maine in a more controlled environment, but I think it does a nice job. R value, because we're Americans, right? We like to have one simple number to throw at something and think that it'll address everything. Well, it clearly doesn't. So here we're looking at R value as it relates to insulation. It does a great job with regards to mitigating cold, transfer of cold, you know, warm to cold. And what it doesn't do is show a really good performance value for the capacity to negate the heat gain through the materials. And so this little vignette will do that. Now on the left, you've got an XPS foam board at an R5. On the right, you've got mineral wool at an R4. And then, as I said earlier, you might need to grow that wood fiber to equal the foam board per se. But in this case, we're going to be right at that per inch value. So we're a little bit less in terms of our value. By all rights, when I push this button and we're going to show the heat gain, in theory, if you believe in the R value and the higher the R value, you get a better performance. In this instance, you're going to find that's not the case. So when I hit this, we're going to turn the sun on, and what you'll start to see when the heat lamps go on, and we've got some thermometers embedded into each one of these materials here, is actually the wood fiber is going to be able to hold off that heat gain. So it's going to really reduce your need for that air conditioning unit to be turned up, if you will, much better than you'll find with the product on the left and the right. So it's one of those things you just can't simply catch with an R value. Shameless promotion, every third Thursday of the month we do a Beyond the R value, and we start to geek out on things of this nature. So hit our website and take a look at our calendar for different topics that we have. But opening the indoors, vapor open assemblies, as we mentioned, we're really great at those seasonalities where you have a high humidity to help diffuse that. And then, of course, the acoustic aspect of it as well. Very compelling there. If you're doing multifamilies or you've got a big home and you're wanting to address the homeowner's concern about sound mitigation, if it's a large family, etc., the wood fiber is a great product to consider. Here's some testing that's been done, and you'll find that the wood fiber does equal to or better depending upon the materials for the gypsum that you're using. You'll see that the wood fiber does a really nice job, be it either wood and or steel. Wood fiber can be used, not just the bat that you're seeing in this image, but also the cellulose can be used and provides quite a nice sound abatement solution for you as well. Again, just wood, 90 and 95% with regards to wood fiber is the bulk of the material for the what we call timber fill, non-toxic to breathe in, no fibers or irritants to the skin. That's so important for the installers. So when you cut it, really the only thing you get is sawdust. The only SDS piece when you're looking at a safety data sheet is that when you're cutting it or blowing it into an attic space or a dense pack, you would want to be using a mask. So looking at time, this is the category that I try to be very, very limited on, because obviously as a manufacturer, especially in the US, and eventually we'll have some Canadian testing done, but for us here in the United States, we're working diligently right now with Phil, shortly with the bat, and then the board to pass and become compliant with all of the ASTM testing. Beyond that, because there's a whole host of you on this call that you just don't want to be code compliant. You want to exceed code compliant, and we support you on that. We get it. Is we are going to spend a long dollar, and it takes 10 to 12 months depending on the testing, life cycle analysis, product declaration, red label, declare, etc. All of that testing will be done on each one of these specific products, and we will publish that, and eventually we will also have that on the product packaging as well. So that's something that will be done. The way that testing works, all of the things that you see that are available today is really based off of the European material that we've imported and tested through a whole host of different testing agencies. That gives us the modeling. There is no proprietary specification on wood fiber insulation. It's been around for 20, 25 years in Europe. But nonetheless, you still as a manufacturer, once you produce your widget coming off your factory line, only then can you put that out to be tested and verified. And that's, again, what's happening right now with the wood fiber. That's fairly straightforward to get some of that R value, fire rating. That's straightforward to get done. But like I mentioned, for those other items that are critical, life cycle, product declaration, declare label, and all of that, that takes a little bit more time, but that is absolutely something that will get done. We want to just be very clear here as it relates to NFPA 285. Wood fiber is for is in a combustible environment. So just like you would with wood framing or OSB or cellulose, that's where wood fiber hits. So we're not to be used in non-combustible applications. That's not where we fit. But really, it's this sweet spot right here for type 3, type 4, type 5. We will be testing multiple different assemblies to be able to have all the various documentation that you need, particularly if you're doing multifamily commercial work. So all the due diligence on that will be done for each specific product as we go to market on that. So, codes are everything. We will be compliant. Fiber is just another week or two away from being ready to go commercialized. All of the sizing that I mentioned for our dimensions of these materials are really being based off code throughout the United States. Climate code maps, IECC in this case, depending upon what state you're in. Obviously, there's a lot of different ways to meet that specific state code. We think that we've done a good job of making sure that those options are there. If not, we can also modify. We do have the ability to change dimensions if necessary. And what's also great is, particularly when you're using our products, whether it's in the bay or whether it's the exterior, it does also help mitigate some of your air leakage and concerns in conjunction, obviously, with the other materials that you would be specified to help address that as well. We're trying to get rid of this, that open flow assembly. I would suspect most of you on this call are extremely dialed in to code and exceeding code. You wouldn't be here if you weren't, because you obviously want to continue to educate. But if you are using a non-permeable exterior continuous insulation, if it's not done to base code and you've got condensation occurring on that back of that plywood or that OSB, that's a concern. But if it's able to dry to the interior, we're okay. It's then when people didn't get the memo that on the inside of the studs up against the sheetrock, you're supposed to get rid of the non-permeable plastic materials and films. That's when potentially some things can go bad. So we're really trying to get rid of it and reduce that risk. We're going to want to meet code, exceed code, and we're going to want to reduce that risk in allowing that assembly to dry out. And wood fiber does allow you to do that. So we're winding down, and I appreciate your patience. Not too much longer to go, just a couple more minutes. I really do appreciate your attention. But we've been looking at the built environment and done a fabulous job with reducing consumption of fossil fuels for heating and cooling over the last 10 years. But one of the areas that's a great opportunity is, what are those materials? So I know that all of you on this call know the phrase embodied carbon. That is really what we're looking at when we look at this category of insulation as an area of opportunity. So anytime you're looking at these various materials that we discussed earlier on in the presentation, what is that raw material? I refer to it as feedstock, right? Is it glass? Is it rocks? Is it newsprint? Is it wood chips? And then that's when you start to look at, how is that harvested? How is that mined? What do you have to do with it in that production facility? What kind of energy is being used to produce that product? What about shipping concerns? Great that we have a mill in Madison, Maine, and that you're in Connecticut. Not so great if you're out in Santa Rosa, California, and interested in procuring our product today. But we will address that in the next year or two. But then the construction, phase. Is it easy to install? What kind of energy is necessary to install that? The use of that building for X number of years, and then the end of life of that building. Can that material be repurposed and reused, or is it landfilled? Can that material be recycled, circular economy, etc.? So these are some things that are being really looked at and scrutinized more because, for what we do, everybody here on this phone, 40% of the carbon emissions in the US is from our industry. And that embodied carbon represents 8.2. And that's the area that not a lot of focus has been put upon up until just recently. And fortunately, that now is in the narrative, and you're here on the call. Most of you, if not all, are members of Passive House, so you're really dialed into this. And then we look at those materials, as I mentioned, mining, making it, transporting it, the use, can it be recycled? Those life cycle analyses are so critical in addition to the energy that's used to procure and make those materials. So great job here where we're plateauing in terms of consumption. We've got heat pumps, we are insulating our homes and buildings more than ever, et cetera, et cetera. But what are those materials? If I had time to do an origin story, the two co-founders, one is a chemist and one is a Passive House architect. It's a fascinating story that starts with the chemist coming out to the Passive House architect before the cladding's on. And the chemist looks at his house, and the Passive House designer says, "Isn't it great? I only need a candle to heat it," tongue in cheek here. And he looks at it and says, "Well, you just designed an igloo cooler. How is that really good for the environment long term?" So that's the focus on that embodied carbon energy. How can we continue to mitigate operational carbon, but do it with materials that might be a little bit more mindful in terms of how they're made as well? So this is the problem that presents itself to the insulation market, and it is ripe for an adjustment, a reset, if you will, to try to help address some of these concerns that are out there today. Here we look at wood fiber today, and we kind of close out. It's a tree. Obviously, our third grade science is the fact that we're going to take that and store that carbon into the tree. If it is cut, it's either going to, or falls in the woods, it's either going to decay, or it's going to be made into products. It's going to be perhaps, burned in biomass, or in this case, we're taking it and making a finished good that's wood fiber. Here's the big one. Most of the materials that we're using address that operational carbon, and it's great. But a lot of those products, unfortunately, have to say, hey, it'll offset for that embodied carbon in 4 years, 5 years, 8 years. Well, here, based upon the production and the way in which we're utilizing wood fiber, recycled material that we're able to take and put into the wood fiber, we're actually able to go in the alternative direction to really help as an alternative in terms of decarbonization. So a really big opportunity here. And we'll just finish out with a couple slides to put things in perspective. If you're looking at a 2x6 construction, and here we're using the wood fiber bat, if you will, you're looking at just a pretty straightforward design here, nothing special, but by taking that wood fiber, you're able to really reduce that embodied carbon. So in essence, in that application, you're taking about 7,100 miles of emissions from driving off the table. And then if you get into the Passive House, which most of you here are obviously very immersed in that, here we're going to double up on this. We're going to go with some continuous insulation, in this case 5.5, and now we're actually going to be able to save 23,500 miles in emissions, if you will, if you're using that in a car analysis. So quite a bit to ponder and think about. It's not for all applications as we've discussed today, but really if you look at that wood frame construction, there's a lot of great applications where wood fiber can now really be thought of as an alternative to what's out there. And the big thing here is that this material will be produced, will be stored at a distributor throughout the U.S., throughout the Northeast particularly, and the lumberyards that may not have any knowledge about this particular product, if you've designed it and they go into a local lumberyard, they're able to find out more information about it and get pricing and have it delivered within a week because the distributors are there to support them. So we're really trying to set it up so that you have the ability to specify it, but also of equal importance is that it's going to be readily available and the cost points are going to be right in play with what they're buying from today. So I'll end there, and Nate or Anna, if there's any questions, if you could bring those to the forefront, that'd be great.
Yeah, sure. Thanks, Scott. That was great.
Thank you.
So first one here comes back to kind of the beginning here, but while continuous insulation layer is required in prescriptive building codes, one can still use res check with trade-offs as an alternative compliance with no continuous insulation, correct?
Yeah, that's I'm assuming that's down in Connecticut. And to be candid, I don't want to speak specifically for Connecticut. But yeah, there are code compliance assemblies that are out there today that are still jacking up the bat insulation with an extremely high R value performance per se. So yes, there are other ways depending on the states that you're in, and I apologize, don't have Connecticut memorized, but yeah, there are a few still holdouts where you can get enough R value in the wall to do it. It's getting harder and harder to do it, but yes. And I know a lot of the reasons for that. If you can mitigate having to put that continuous insulation, certainly it makes the life of the contractor much, much, much easier. We totally get that. Totally get that. Sorry, I couldn't give you 100% answer on that. I kind of did a little political dance.
No problem. No problem. Is there one other question here is there available exterior these insulation boards? Are they available for exterior finished siding, or have we not got there yet?
No, we haven't gotten there yet. I mean, we're gonna, and I use this phrase all the time. We're gonna crawl, walk, and run. Europeans have been doing it for years, right? So we've got to get proof of concept here. In other words, we defied some of the critics in the sense that we have a plant that's operational now. We're bringing people back to work, and now we have a tremendous amount of folks that are interested in what we're doing. And our number one goal is to get the fill, the bat, and the board at 100% production the way that we show it today on our website. There are a lot of skunk work projects out there. But today, to address that, we really want that to be cladded. Now, on the inside, like if you're doing a retrofit in an old masonry building and down below and you can't dig up around the foundation and you want to reduce some of that thermal flow, we have some folks that are actually looking at the timber fill and leaving that exposed. Now, a lot of that has to do with code compliance with regards to the fire code in that case. But if it's in if it's in an application where there's no fire code concerns per se, that's either being exposed and or in that case could be painted because it's not going to be exposed to Mother Nature. But we're looking at all kinds of things: suspended ceilings with sound attenuation. We see all kinds of different insulation exterior components that could be made with this as well too. There's a lot of neat things coming.
Great, thanks. One other one, I'm going to try and just rephrase it here. The bats, the timber bats, are they actually 6-inch or are they 5.5 inches like fiberglass? If they are 6 inches, do they get compressed and do they lose any insulation value?
Yeah, no, they're compressed in play. We have them a bit oversized so they could be cut. So if you have some framing that's off. But yeah, it's compression fit is how that's in place. I used this myself this summer, European, mind you, just to be clear. We're not quite producing the bat yet. We will be soon. And it was a pleasure to work with. And I was doing it up in a ceiling cavity, and it was awesome. I mean, it was a 100% pressure fit and easy to work with. And that
Perfect,
gets
okay.
rid of that wind washing too, particularly in the wall applications on the exterior wall.
All right, and since just for clarity here, I mean, I assume that it probably is because it's mixed with the same materials as cellulose, but is the material pest resistant?
Well, that's a really great question. That does come up all the time. And for those of you, I would suspect most of you, I was trying to get back to this earlier slide, so forgive me. The reality on that is your detailing. Pests, when they're very cold, I'm up in Maine and we have a seasonal place in one of the islands. And when those mice are really, really, really cold, you know, they can sneak into something about a quarter in dimension. They're going to get in. And that's whether it's mineral wool, fiberglass, or even wood fiber. So I don't want to misrepresent that whatsoever, but they're not likely to necessarily ingest it, but they are a nuisance if the flashing details and mitigation of the details, you know, to the exterior to allow them to come in aren't addressed. I certainly do not want to misrepresent and say that, you know, they're going to, you know, turn around and head away from that wood fiber insulation. That wouldn't be the case. I'd be misrepresenting if I said it was.
All right, great. And just a couple more here. The wood fiber exterior board, is that an approved weather-resistant barrier?
No, not. It's not. So it's purely thermal, and there is no structural component to it. So purely right now, again, you know, crawl, walk, run. We're going to be utilizing this just like the other continuous insulations, whether it was a foam board or mineral wool per se. I purposely leaving our sheathing out of it. So this is going to be overlaid onto your whatever you've picked for shear and for bulk water and water management. So you're going to do that first and foremost, and then you're going to apply our product purely as thermal.
Great. All right.
I will say on that note,
sorry.
Nate, I'm going to, on that subject matter, we're really lucky. We have Joe Stebrick that's doing and building out our detailing models. So we're going to get extremely granular, not only for you as architects. I know there's probably a few remodelers and contractors here too. We're going to really dive deep, particularly here on the continuous insulation. You know, you've got MEPs, you've got window details, roof conditions, and things like that. So we're going to really detail that out with a multitude of different options. You know, there are some that want to be redundant. Here again, we're in New England. So we'll show some detailing so that you do your traditional vapor bulk water management on whatever it is you're using, apply ours, and then we'll show you some other membranes that can be used as well too. We'll also have a lot of videos. We know attention spans on the training side. For some, they're not going to want to read per se. They're going to want to see videos. So we're going to put a ton of effort into showing a lot of these installations in that fashion as well.
All right. Thank you again. And the last question we have here is about cost comparison. Roughly, if you have a new construction wall with fiberglass bats in between the joists and rigid foam board on the side, what's the cost comparison roughly between that setup and that assembly versus an assembly with Timber HP's products as far as the bats and the continuous?
Yeah, I'm just pulling this up for those of you that missed our information. Sorry, I'm not skipping that question. I'll come right back to it, but I know we only have a few more minutes. I'm trying to. There we go. So what we would propose that you do, because it's so new, and this is why I'm putting up my screen here if it'll show. We would advise that you give Paige or give myself a call. I don't know why that's not populating. I'll try to be patient. Did that just come up? Let's see. There it is. What we want to do is handhold that pricing piece. Problem that you have is that if it's brand new and you get involved and you start pricing that out from a retailer that's not, or a contractor that's not familiar with it, you get the old 10% add-on, right? It's new. I've never used it. I'm going to throw 10% on. So we've spent a ton of time working with Cameron Ashley. They're a national distributor. They have 50 facilities throughout the U.S. They're going to actually inventory this for us so that the retailer doesn't necessarily have to stock it straight away. And so that helps us bring that cost to be very competitive so that when you've specified it, the retailer can very quickly get a price on that and can be delivered straight away. But in this particular case where it's brand new, if you were to go into Connecticut, Rhode Island, or New York and just pop into one of your favorite lumber yards and ask somebody behind the counter about timber HP, there might be some synapse, but there might not be. And this is what really concerns us now. And that's what Paige is doing, is she's spending an extraordinary amount of time educating. I'm working with architects and developers and such. So we're asking that you give us a call so that we can actually handhold it. Fiberglass, as I said, no matter what, that's going to crush us. That's just the lowest cost denominator. But if you're looking at, and if you've used mineral wool and you're using an exterior board, I forget what the example was that they're using. If it was foam, let's say, we're going to be right there. We're going to actually, if it's mineral wool that you've been using, we should be less. We should be less. Fiberglass is the only area that's going to still be more aggressively priced. Cellulose, if you're looking at that, we should be right on par. We might actually come in a little bit less as well because it's getting harder to find it at an aggressive price. I don't know, Nate, did that cover that question?
Yeah, I think so. Absolutely. Absolutely. So I think that's pretty much it. That was actually my question too for you, was that kind of along the pricing ranges here. So that's great.
Listen, we want to do stuff. We're working on a lot of commercial work. And what's nice is when we work with you on that, we can lock it in too, because we want you to use it and we'll take the hit if market price for X, Y, and Z goes up. We want to get some folks using it. My email address is there. Paige's email address is there. If you want us to come into your office, do this similar presentation for everybody there, or a product knowledge workshop that speaks specifically about our product, please shoot us an email. We'd be glad to help you. Or if you want to email me right now and just say, hey, Scott, can you like make my life easy and just send me the pertinent documents? Send me a note. Say, hey, Scott, just give me the shortcut notes. I'll pull the really poignant parts and email those to you with a couple of other cool things like an origin story with Matt and Josh that talk about how they launched this. Plus, I've got a PDF document of Down East Magazine's August edition that talks about how they brought that mill back to life. So shoot me a quick email and I'll respond to you today. So thank you both for coordinating this. This was fun. I appreciate the exposure.
Of course. Yeah, no, this was great.
I definitely see this as not being the last time we speak as far as this is concerned.
Well, please light us up. Email Paige, email me. We'd be glad to help see you in person and bring a lot of our toys. That way you can see it, feel it, and touch it. So, thanks, everybody. Have a great afternoon, and thank you so much for your time. I appreciate it.
Yeah, thank you, and have a good rest of the day to everyone. Thank you.
Thank you.
Thank you.
Bye.
Thank you.